Okay, this lesson is pretty short. There's not a whole lot involved. It talks about the graph of the logarithmic function and then kind of compares it to its inverse, the base 10 exponential. So what you have here that you see are the graphs of y equals log of x, and also you have the graph of y equals 10 to the x, okay? So we'll be talking about things we've talked about before with graphs: domain, range, concavity, and asymptotes, okay? So really those are things that if you know what the graphs look like, they're not really that difficult to find. Just remember though that these graphs are inverses of one another, meaning that the domain of one is the range of the other and vice versa. We'll use that fact when we find domain and range. And then graphically, looking at inverses, it means that one graph is reflected over the line y equals x. So if you kind of think back to geometry, if you think about taking y equals 10 to the x and reflecting it over this line, it would be your base 10 log function. All right, so with that being said, we are going to look at the graphs of these functions to determine the domain and range and concavity. So let's start with our log function. So that is here in blue. The domain of our log function, you can kind of see that it's continuing on towards big X values, but once it gets close to 0, it kind of veers down with an asymptote. So our domain of our log function is that X has to be greater than 0. The range, however, this, although it looks like it's kind of flattening out, it is slowly getting bigger here to the y values and then goes down towards negative y values. So the range of this is all real numbers. Actually, let me just use the symbol here. So then when we are looking at domain and range for our y equals 10 to the x, like we said, because these are inverses, the domain and range is just flipped. So if you look at the domain of the green graph, it goes from negative x values and it will increase eventually towards positive x values. So the domain is all real numbers. The range, however, has to be greater than 0. The concavity for the log function, the concavity is down. But it is an increasing function. So remember the difference between those two things. The fact that it's an increasing function means the y values are getting bigger. It is concave down because the rate of change is decreasing. Our y equals 10 to the x function, this function is always also increasing, but it is concave. Oh my. But it is concave up. All right, looking at the asymptotes of these functions, hopefully it's becoming easier for you to recognize asymptotes of graphs. For our log function, we do have a vertical asymptote right at 0. That's what determines, its domain a little bit. So we have a vertical asymptote at x equals 0. And for our exponential function, we have a horizontal asymptote. At y equals 0. Okay, we talked last unit about how exponential functions always have a horizontal asymptote. So now with our log functions, these will also always have a vertical asymptote. Okay, so kind of looking at a similar graph here, this is just with our natural log function and our base e exponential function. Same thing here, natural log and base e exponential are inverses. The domain and range and asymptotes are going to be almost identical to what they were with our base 10 and our base 10 log function. So if we look first at our natural log function, again, we see the domain has to be greater than x, and our range is all real numbers. With our y equals e to the x, again, kind of similar thing. Our domain and range is flipping. So now our domain is all real numbers. The range y has to be greater than 0. For the asymptotes, again, we have an asymptote at x equals 0 for our natural log function, and an asymptote at y equals 0 for our y equals e to the x function. Okay? So again, not a whole lot of information here. Just kind of understand those generalities, domain, range, asymptotes for our log functions and then our exponential functions. There is one other thing to look at in this unit, and it's just kind of a little application. I'm really not super duper concerned with problems like this. And actually, I think we'll just kind of save this for class next time. It doesn't take long to go over, so we'll just do this next time.